I know it was. So what else are you going to think about? What are you going to think about in the situation? You are going to do risk assessment.
Approach.
Yeah, which way are you going to approach? Which way do you send your team in, typically?
Upwind.
Upwind, right? Upwind, uphill. So that means you're going to have to make note of what? Wind direction, topography, wind speed, are all those pretty critical?
Trains.
Yeah, trains. What else would you think about as you look at the package? Did you say train?
Drains.
Drains? Well, let's talk about that. Do we have to think about off-site receptors? What if you got, nitric acid headed toward the trout stream? Is that going to go into your mind about, okay, I need to send a team in to start containment over here or something? Yes? Keep going. No bad answers.
Well,
As we see from him.
storm drains.
Yeah, you may have to send a team in to plug up the storm drains, right? Because if it gets in the storm drain, it's going to find right to a body of water, right? So limiting the extent of contamination. What else we have to make a decision? How about anything on the package that you want to see? How fast is coming out? How bad is the breach? Is it exhaust its contents? What?
How big is the possible
How
release?
about the extent of it? How big is it? Is that going to make a difference in how much spill control material you're going to need? Where you're going to set up containment? Would you probably in a high level protection, would you do air monitoring if you could? Get some information to compare to our PELs and our IDLHs and our LELs. Is that good information to have? We probably have to do that. And what do you think, a level A or B initially, just to kind of see where we are? But sooner or later, you're going to send a team in, then you're going to start this, right? The first thing the team is going to do is mitigation. What does mitigation mean? Big fancy word for what?
Isolate.
Stop.
Okay, isolate it, stop the leak, anything we can do to stop the flow of the material. And obviously, if everything leaked out, there is no mitigation. In general, what are some ways that we can do that?
Close the valve.
Close a valve, right? In a facility, if you've got a leaking pipe, can you double block it, bleed it out? That's mitigation. What about a 55-gallon drum that's leaking?
Turn it over.
Turn it over, right? It could be something from simple to complex. Plugs, patches, if any of you have done this like full-time, would you have a big thing full of plugs and patches and wedges, made out of rubber, wood, every type of material that's compatible? That way you can stop it as soon as you can. And of course, we have escaping material, right? Or escaped material. That leads us to number 4. What's the 4th one?
Containment.
Containment, right? Different things you do that you can do to limit the spread. Why is it important to do a job of mitigation and containment if you're a team? What do we know about as good a job we do there?
Reduce the risk.
It's going to reduce the risk, right? And also, everywhere that chemical goes, we got to do what? They got to clean it up, which puts more people at risk and increases the overall cost. Then, of course, we get to the fun stuff. Big fancy word here. Yeah. Well, why don't we just call it cleanup? But no, abatement. It costs more per hour if you charge people for abatement cost, not cleanup cost. So abatement, anything we need to do, could that include neutralization of acids if we need to do that to get the pH to 6 to 8? Anything we knew, and again, that's not really all that fun. You have shovels involved in digging up things. And back when I did this full time, one of the things I always try to do is to see if I could do air monitoring to get a downgrade in level of protection. Is it almost impossible for somebody to dig soil in the level A or level B ensemble? I mean, you just kill them. I mean, heat stress.
Unless you're on a backhoe.
Yeah, on a backhoe, I guess that's probably true. Still, you're going to be limited though, right? So we always took a look at that. And finally, as we know in a TSD, we can't throw that material in the back 40, right? Hazardous waste. It has to go to someone like us, a licensed treatment storage and disposal facility. Everybody knows about cradle to grave, right? All right. Talk about air monitoring. Let's go over to page, I had the page number up there.
51.
Got, okay. What page is it? 82. I don't think there's anything in to write in here. Just want to kind of remind you of a couple of principles here. When we talk about our poric gas meter, we have a LEL sensor, right? An oxygen sensor. It's in there, don't worry about it. We're not going to write anything down. And we have a toxic sensor. How many people remember the order in which we would test? We have a confined space, we have that poric gas meter, what are you gonna monitor for first?
LEO.
Nope. Oxygen, right? We always do oxygen first. Why do you think that is? Well, that's a plus, but it's actually related to the second one, LEL. So if I calibrate the LEL sensor here in 20.8% oxygen, and I take the meter to an oxygen deficient environment, it's going to be wrong, right? So if we look here, if the oxygen is already deficient, we're going to stop, take care of that problem, and then we will go to LEL, and then finally, of course, we do our toxic chemicals last. H2S, CO, benzene, whatever it's called for on the exposure situation. Everybody remember that? Because this may come up on something that we're getting ready to do. Standards. You're not have to write these down, okay? But just remember, LEL greater than 10%. We mentioned that one. That's IDLH. Oxygen, remember this one? Deficiency, and what do we call this one?
Enrichment.
Enrichment, greater than 23.5. On the toxic side, if I do air monitoring on a spill in the, like for pneumonia, and it's already over the IDLH, what kind of suit does that put me into automatically? What level? Level A. Anytime you're over IDLH for that particular chemical, you're automatically going to be in level A. Okay, which brings us into protective clothing. This is in there. You don't have to write it down. I'm just refreshing you. Can I just go get a glove off the shelf for any chemical and say, oh yeah, that'll work for all chemicals?
No.
No. We have to look, someone like me has to look at his permeation data. Remember permeation? You get liquid on a glove or clothing material, perfectly intact. Can some of it go through diffusion very fast? So when I did this full time, I would pick a glove, I would know the chemical, I would give my guys the glove that gave me the longest breakthrough times. Okay, longest breakthrough times. So that was the permeation selection. Degradation. What happens when you leave rubber products out in the sunlight?
Break down.
They break down. Well, some chemicals do the same thing to some glove and clothing materials.
Yes.
Okay, so nitrile gloves, PVC gloves, etc. And then finally, of course, everything is made and manufactured. How many people have worn a pair of tie-back and you just bend over and the seams rip open? Okay, or you have a dipped glove that has a pinhole in it. So this is really a lot about inspection, making sure you have an imperfection in your glove. So we use those different things to select glove and clothing material. Everybody remembers this one, right? What is the highest level of protection? Level A. How many people have seen a level A suit? I think we have quite a few. Totally encapsulated, vapor tight, chemicals can't get in, right? It's positive pressure. So you got an SCBA on the back, right? Positive pressure in the face piece. So highest level of protection that we can get into. Level B is still pretty high. Level B suits are thinner and lighter, not as many layers as you know. Still a high level of respiratory protection. Airline, grade D breathing air, 5-minute escape bottle typically, or you can have an SCBA. And then of course level C is a major downgrade. This is, what kind of respirator are these? Air wash. Purifying. Air purifying, full or half face, no air supplied. And then of course level D, what you come to work in, pretty much. Right? All right, who remembers this one? Site control, page 53. You can go to this one. See if you can find that picture there. This is our last slide. And everybody says, yay, that's it. Hey, am I getting through the book good now, John?
Yeah.
Yeah, okay.
I thought you might like that.
Is it important to have control over your site, your spill site?
Yes.
Or your cleanup site? What will happen if you don't have control over your spill or cleanup site?
People are causing that.
Yeah, you're going to get cross-contamination, get people tracking through it. The news media, will they get right in the middle of it? Yes, if it's toxic, just let them come on in. That's where they go. So we want to have control over our site because we know that anywhere chemicals move, we're going to have to do what?
Clean up.
Clean it up. So as you will recall, we have 3 different zones that we designed. We have the exclusion zone, also known as the what?
Easy.
What is the EZ? Yeah, we do call it that. What does the fire department call it typically? Hot zone. And this is where all known contamination and all of that mitigation, containment, abatement, disposal is going to go on. As you remember, we marked that by the what? Hotline. So we will physically mark that so when workers go in over that hotline, they know they need to be in the level of protection that's been assigned. They need to have the SCBAs on, air purifying, whatever it happens to be, depending on level of protection. Are we concerned about decontamination of tools and workers? You want to have a zone to set that up in, right? So right here in the second zone, contamination reduction zone, upwind, that's where we're going to do our decon operations. We're going to mark that so people know it's there by the contamination control line. Step over that, you're ready for a field shower into the third zone, the support zone. So hot, warm, cold. Actually, these are the official names that we actually call it in real life. Okay? So is this kind of an administrative control? We set up these little artificial boundaries and tell people where they can and can't go. Will this help you minimize movement of contaminants? Because we really want to centralize everything to come in through where? Through here? Are we going to have swimming pools and everything to, when we do decon, to capture any water or any contaminants there? Okay? So is this good to have if you have a spill site?
Yeah.
No doubt about it. Uh-oh. That's right, absolutely. Here's what I need you to do. I need you to go ahead and clear the desk. And what I'm going to do is I'm going to switch some positions here to make sure we have teams that are fairly even. John, I want you to come on this side. Carla, I want you to go on this side over here. So I want you guys to switch locations. So we're going to have this first four right here. Sharon, if we can get a